All right, so here is the third and final video for the reflections section for transformation. So we're going to do the same thing we've done in the last two videos, where we're going to go through and we're going to graph our figure, and then we're going to reflect over a line. This time we're going to reflect over either y equals x or y equals negative x. So we'll take a look at what those look like in just a minute. So first, let's go through and graph our, in this case, triangle first. So we're going to go -5, so 1, 2, 3, 4, 5 left, and then down 2. So we have x, and then y is 3 to the left and 1, 2, 3, 4 up. So there's y, and then z is -1, +1. So there's z. All right, so here is my triangle that I'm going to reflect over. Or that I'm going to reflect over this other line. So I have my 3 points graphed. Now I need to look at this y equals x. So this is kind of going back to y equals mx plus b. And I know we kind of covered this in class really quickly. But this is going back to just graphing a basic line. So remember, m is our slope, and b is our y-intercept. So super quick notes on these two things. So if I don't have a number in front of x, it's automatically a 1. So my slope for this line is 1. If I don't see any number being added or subtracted, then it's +0. So I'm going to go to 0, and then I'm going to go up 1 over 1. So rise over run, up 1 over 1, up 1 over 1. So, and I can do that all the way from corner to corner. So let's see if I can connect that nicely. Ta-da! So x equals 0 is a nice, very uniform diagonal line from corner to corner, but it's from the bottom left corner to the top right corner. So it's a positive slope because it's going up from left to right. All right, so now if I want to map these ones, so these ones are a little bit different on mapping. The other ones we mapped either straight across or straight up and down. With these ones, they're a little different because we have that diagonal line. It's actually going to take a turn. So what I want to do when I'm mapping these ones, if I go x and I go, it's 1, 2, 3 away from that line, instead of going 1, 2, 3 this way, what I'm going to do is go down. I have to turn and go 1, 2, 3 like that. So that's where x prime is actually going to end up, is right here. And we can even think about that if we folded that on the yellow line. If we could fold this paper, those 2 points would match up. But if I had gone straight over here and we folded that paper, they definitely would not match up, right? So it's just kind of that weird little turn we have to make sure that they do match up. So now if I want to know the coordinate, I'm going to go left 2 and down 1, 2, 3, 4, 5. So those are both going to be negative. So -2, -5. All right, now let's go with y. So y is 1, 2, 3, 4, 5, 6, 7 away. So I'm going to go 1, 2, 3, 4, 5, 6, 7. So there's my y prime. And with this one, it's 1, 2, 3, 4 to the right and down 1, 2, 3. So it's +4, -3. And then I'm going to do one last one here for my z. So z is 1, 2 away. So I'm going to go 1, 2 down. I'm going to put my point here for z. So z prime. And I can connect these now so you can see it's the same little triangle, and it's definitely flipped over that yellow line. We just have to make that turn to make sure that it flips. So z is going to be +1 to the right, down 1. So it's going to be, I'm going to get rid of those lines real quick. So +1, down 1, like that. So really quick, I'm going to kind of zoom in here, and I'm going to compare so that we can write a rule for these ones. So if I look at x and x prime, and then I look at y, and I look at y prime, and then z is -1, 1, and z prime is 1, -1. So with these ones, it's a little different because none of them are actually staying the same. I can't go through and highlight and go, oh, well, the x's are the same. No, they're not. Or the y's are the same. No, they're not. But I can see that there's this thing happening kind of across. Ooh. highlight that much. There we go. I just got to put my pencil a little bit more straight up and down. So it's kind of doing this crisscross thing. I can see -3 to -3, and then I can see 4 to +4, and again 1 to +1. So it's doing this like crisscross thing. So it's switching. So the rule here, so if I'm reflecting over y equals x, I'm writing it backwards, y equals x, then I take xy, a point xy, and I'm simply just going to switch them around, and it's going to flip them. So y becomes x and x becomes y. That's the basic rule. So we can actually use that on the next one here. If we scooch over to number 10, let's go ahead and graph number 10. So we're going to graph our rectangle. So we have G is +2, -1. So there's G. H is +7, -1. Oh, weird H. So that's H. I is +7, -4. So 1, 2, 3, 4. So there's I. And then J is +2, -4. So this one is pretty square with the coordinate grid, but because we're doing a diagonal line, it's not going to matter as much, because remember, we're going over this diagonal line, which since it's y equals +x, it's going to be from corner to corner, like that. Let's see if that straightens out a little bit. There we go. So that's my line of reflection that I want to use. So before I even map this, I can use that rule that we just came up with, right? So I know it's going to go x, y, and it's going to change. It's going to go y, x. Nothing, the signs aren't going to change. They're just going to switch spots. So if I know that that's the rule, I can just take that. So if I look at this G, I'll just underline it. So G, it's going to go -1, 2. I'm just going to flip them around. H, it's going to go -1, 7. I is going to go -4, 7. And J is going to go -4, 2. So now let's confirm that with our counting here. So now if we go G is, and it doesn't matter if I go this way or this way, whichever way I count. So I can go, it's 1, 2, 3 away, and then I go 1, 2, 3. Or I can go, it's 1, 2, 3 away, and 1, 2, 3. If you notice, either way, I land in that same exact spot. It doesn't matter which direction I count from. I just need to make sure I make that 90-degree turn in order to land in the right spot. So with this one, I go -1, +2, -1, +2. So the rule does in fact work. So now if I go H, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. So now 1, 2, 3, 4, 5, 6, 7, 8. So there's H prime. And again, that's -1, +7, -1, +7. All right, next one here. So if I go I, so I is 7 or 8 away, but it's also another 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 away. So now I'm going to go 7, 8, 9, 10, 11. So there's I. And I cheated a little because I know that that is 7. So that's how I did 7 so quickly without just counting it. So now if I look at the coordinates here, this is -4, +7, -4, +7. So it worked out again. All right, last one is J. So we have 1, 2, 3, 4, 5, 6. So I'm going to do that same thing. 1, 2, 3, 4, 5, 6. A little glitchy on the iPad here. All right, so that's J prime. And again, if I want the coordinate for that, I'm going to go 1, 2, 3, 4, negative, and 2 positive, 4 negative, and 2 positive. So that did in fact work out using that cute little rule. And again, the rules are going to be really, really beneficial when we come up to situations later where we're doing more than one transformation at a time. So instead of having to graph each and every transformation, we could in fact just use the rules to help us go a little bit faster through this. Instead of having to literally count every single change. But graphing it is also a perfectly legitimate option here. Okay, so now we're going to do the same idea we just did, but if you noticed, we're going to do y equals negative x. So we'll talk about that in just a second. First, let's graph these pieces. So we're going to go A is negative 1, 1, 2, 3. So there's A. B is 0, 6. So I'm just going to go straight up to 6. 1, 2, 3, 4, 5, 6. So there's B. C is 1, 2, 3. 1, 2, 3, 4, 5. So there's C. And then D is 1, 2, 1, 2. So there is the square that I'm going to be reflecting. All right, so now let's talk about the line that it's reflecting over. So we have our 4 points. So it's reflecting over y equals negative x. So again, if it's y equals mx plus b, that negative in front of the x actually means negative 1. So my slope is negative 1 over 1. And then I have nothing after it. I don't have that plus b. So that just simply means, again, plus 0. So I'm still going to start at 0, but instead of going up 1 over 1 like I did on the last one, I'm going to go down 1 over 1. Okay, so it's going to go down like this. So it's another very nice diagonal line from corner to corner. We're just starting in the other corner. So it's a negative slope on this one, going from the top left down to the bottom right. All right, so now we're going to go through and we're going to map this out and then look at the rule for this one. So A, this is the same thing. We're going to make that sharp turn. So I'm 2 away. So I'm going to turn and go 2 away. So I have A prime here. So now this would be negative 3, positive 1. Negative 3, positive 1. All right. So B is 1, 2, 3, 4, 5, 6 away. So we're going to go 1, 2, 3, 4, 5, 6. So here I'm going to go right on here, B prime. So now I'm going right over to 6. I'm not going up or down. So I'm going left 6 and then 0. All right. And then my next one. So C is 1, 2, 3, 4, 5, 6, 7, 8 away. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. Wiggly line a little bit there. C prime. So now I'm going 1, 2, 3, 4, 5 to the left and 1, 2, 3 down. So those are both negative numbers. So 5 left, 3 down. All right, last one to map here. This is 1, 2, 3, 4 away from the line. So I'm going to go 1, 2, 3, 4 away from the line. And there it is. So now the coordinate for this one is negative 2, negative 2. So it's negative 2, negative 2. I'm going to go ahead and connect these. Boop, boop. So I can still see, I still have my square. I can definitely see like this space in between here looks to me like it's that same shape. It kind of looks like a little triangle here. And that to me looks like the same triangle on either side, like the shape that it kind of, the void it makes. So it definitely looks like it reflected over that line correctly. So let's go ahead and look at the comparison here. So I have A, negative 1, 3. A prime is negative 3, 1. B is 0, 6. B prime is negative 6, 0. C is 3, 5. And C prime is negative 5, 3. And I will put D down here. So D was 2, 2. All right, so if we take a look at these just like we were on the last one, they kind of sort of do that crisscross thing that we were seeing. But there is a slight difference. They also change signs. So if we look, negative 1 went to positive 1. 3 went to negative 1. So same thing here. 6 went, oops, why did it go to eraser? 6 went to negative 6. Zeros don't change, so those look like they stayed the same. And then for C, it goes 3. Oh, that should be a negative 3, darn it. I didn't write my negative on there. So, well, go to pen. Negative 3, that should be a negative 3 there. And then the 5 went to negative 5. And then same thing here. It went from negative 2 to positive 2 and negative 2 to positive 2. So they do flip-flop sides, but they also flip-flop signs. So reflecting, forgot to change back to pen, darn it. Reflecting y equals negative x, So now I have my point XY, and it's going to change. So X and Y are going to change spots, but they're also going to change their sign. So if they were positive, they're going to be negative. If they were negative, they're going to be positive. Again, don't let this think that we're going from positive to negative every time. It's just telling you that it's flipping signs. Okay, so that's the rule. So let's see if we can use that rule for number 12. So again, I'll just write it here. So X, Y. So we're going to flip. It's going to go negative Y, negative X. So they're going to flip positions for the coordinates, and they're going to flip signs. All right, so let's go ahead and graph first, and then we'll go through and work on that rule. So S is -1, so left 1, down 6. So there's S. T is just straight down 3. And then U is +1, 2, 3, -1, 2, 3, 4. So that's U. So there's our triangle. Okay. And then again, we have Y equals -X. So I know it's from corner to corner. Let's see if I can draw this nicely. There we go. I like that nice snap feature there. Okay, so I have my line of reflection. So let's see if we can apply this rule first before we go through and actually map it. So with this one for S, they're going to switch spots. So it's going to be -6 and -1, but they're also going to switch signs. So it's going to become 6 and 1. Because they're switching from negative to positive. T, when we switch, it's going to be +3, and 0 doesn't switch signs, so that's just going to stay 0. And then our last one here, so it's going to be -4 is going to switch to +4, and 3 is going to switch to -3. So I have my 3 spots. Let's make sure that this worked correctly. All right, so now if I start on S, I'm going to go 1, 2, 3, 4, 5, 6, 7 away. So now I'm going to go 1, 2, 3, 4, 5, 6, 7 away on that very sharp bend. So there's S prime. So now if I look at the coordinates, this would be 6 positive up 1, which is exactly what we have here from our rule. So 6, 1. All right. The next one, we're going to go T. So T is 1, 2, 3 away. So I'm going to take my turn and go 1, 2, 3 away. So that would be right here. So here's T prime. I'm going to scooch T off to the other side so it's not right in the middle. T prime, there we go. And again, to map this, I would just go over 3 and stop, which is exactly what this is telling us that we figured out with our rule. And the very last one here, U is 1 away, so I'm going to take my turn and go 1 away. And U prime will be right there, which this is 1, 2, 3, 4. And then 1, 2, 3 down, +4, -3. So that worked out just fine using the rule. So using the rule or the mapping, either one works. I'm going to definitely continue to teach the idea of using the rules. Mainly because that it'll save us time as we're going forward and we're combining these skills, because we're not just going to keep doing one thing at a time. As we learn more transformations, we're going to start doing reflections with transitions, with rotations, and even dilations. There's going to be a lot going on in some of the problems. So that's the end of part 3. I hope that helped, and I will see you in the next video.